Hi, welcome to my new video of Python series. Today we are going to learn about the copy behavior in Python, i.e. deep copy and shallow copy and thier behavior, and an example to understand. Before starting the video, if you are new here, please subscribe the channel and hit the bell icon to receive every new video updates. Also do check out other videos on our channel, I will attach link in description. How does copy an object works in Python? In Python, we use =sto operator to create a copy of an object. You may think that this creates a new object. It doesn't. It only creates a new variable that shares the reference of the original object. Let's look at the snippet. We have a list called oldList, and we are going to assign the list to new variable called newList. When we run above program, the output will be. As you can see from the output, both variables oldList and newList shares the same ID. So, if you want to modify any values in newList or oldList, the change is visible in both. Essentially, sometimes you may want to have the original values unchanged and only modify the new values or vice versa. In Python, there are two ways to create copies: shallow copy, deep copy. To make these copy work, we use the copy module. We use the copy module of Python for shallow and deep copy operations. Suppose you need to copy the compound list, say X. For example, here, the copy return a shallow copy of X. Similarly, deep copy return a deep copy of X. Let's understand the shallow copy first. A shallow copy creates a new object which stores the reference of the original elements. So, a shallow copy doesn't create a copy of nested objects, instead it just copies the reference of nested objects. This means, a copy process does not recurse or create copies of nested objects itself. Let's take an example. We created a nested list and then shallow copy it using copy method. This means it will create new and independent object with same content. To verify this, we print the both old list and new list. To confirm that new list is different from old list, we try to add new nested object to original and check it. Here we added a list and append it to the old list. When we run the program, it will output this. In this above program, we created a shallow copy of old list. The new list contains references to original nested objects stored in old list. Then we add the new list i.e. into old list. This new sublist was not copied in new list. However, when you change any nested objects in old list, the changes appear in new list. Now, adding nested object to the old list. When we run the program, it will output. In the above program, we made changes to old list. Both sublists of old list and new list were modified. This is because both lists share the reference of same nested objects. Now, look at the deep copy. A deep copy creates a new object and recursively adds the copies of nested objects present in the original elements. Let's continue with the previous example. However, we are going to create deep copy using deep copy function present in copy module. The deep copy creates independent copy of original object and all its nested objects. In this program, we use deep copy function to create copy which looks similar. However, if you make changes to any nested objects in original object old list, you'll see no changes to the copy new list. Now we are going to add a new nested object in the list using deep copy. In this program, when we assign a new value to old list, we can see only the old list is modified. This means both the old list and the new list are independent. This is because the old list was recursively copied, which is true for all its nested objects. So, for now we have learned what is copy module, how it works, how the deep copy and shallow copy works in Python, and what is the science behind the scenes. If you have any question in your mind, do not hesitate to ask your queries in comments section. I will try to answer each of your queries. Also do check out my other different videos. Stay tuned for upcoming videos. Until the next time, good